Imagine you're building an email notification service that needs to process 100,000 user emails at the same time. The big question is, which backend technology handles this better, Node.js or Go? Both are popular choices for scalable backend systems, but their memory usage can make a huge difference in performance and cost. In this video, we'll break down how each handles memory, why Go often comes out ahead, and what that means for real-world application. Let's start by setting the stage with a simple analogy that makes these technical differences easy to understand. Think of memory like hotel rooms. In this analogy, Node.js is like an inefficient hotel with tiny rooms. Each promise is a small room, only about 200 bytes. That sounds cheap, right? But the hotel also needs a massive lobby, parking lot, and staff areas, which take up a lot of space. Go, on the other hand, is like an efficient hostel. Each goroutine is a bigger room, about 2 KB, but the hostel has a tiny lobby and shared facilities, so the overall infrastructure is much smaller. This analogy helps us see that it's not just about the size of each room, but the total space the hotel needs to operate. Let's look at Node.js first. For 10,000 concurrent promises, the rooms themselves only use about 2 MB, but the hotel's infrastructure, the V8 engine, garbage collector, and event loop, adds another 50 to 100 MB. That means the total memory usage is between 52 and 102 MB. When you scale up to 100,000 promises, the numbers get even bigger: 20 MB for the promises, 300 MB for the V8 heap, and 50 MB for the event loop state. Altogether, Node.js can use around 370 MB of memory for this workload. Now let's see how Go handles the same scenario. Each goroutine uses about 2 KB, so for 10,000 goroutines that's 20 MB, but Go's runtime overhead is much smaller, only about 5 MB, so the total is just 25 MB. When you scale up to 100,000 goroutines, the rooms use 200 MB and the runtime overhead is only 10 MB. That brings the total to 210 MB, which is about 43% less than Node.js for the same workload. Go's efficient use of memory comes from its lightweight runtime and stack-based memory management. Node.js ends up using more total memory for several reasons. First, the V8 JavaScript engine creates lots of objects in memory for each promise, including closure variables and callback references. Second, garbage collection in V8 requires extra memory, often 2 to 3 times more, to work efficiently. Third, Node.js tracks pending callbacks, timer queues, and I/O watchers, all of which are stored in the heap. These factors combine to create a large runtime overhead, making Node.js less memory efficient at high concurrency. Go takes a different approach. Each goroutine gets its own small stack, starting at 2 KB and growing only if needed. When a goroutine finishes, its stack memory is instantly reclaimed. No garbage collection scan required. This stack-based model means Go doesn't need to keep extra memory around for garbage collection, and the runtime tracking is minimal. As a result, Go can handle many more concurrent operations with less total memory, making it ideal for high concurrency backends. Let's put these numbers into perspective with a real-world example. On a server with 1 GB of RAM, Node.js can handle about 50,000 concurrent operations before running out of memory. Go, on the other hand, can handle up to 500,000 concurrent operations on the same hardware. That's a tenfold increase in capacity. This efficiency also translates to cost savings. For the same workload, a Node.js cluster on AWS might cost $70 per month, while a single Go instance